Now this is the first one of the interest tickets we'll look at here. So we're looking at which of the following inequalities correctly matches the number line graphs below. So we have this here, yes? We have two different lines that are being graphed, and they're going in opposite directions, yes? This tells me for certain that A and B are not going to be it. Because whenever we talk about an and statement, both have to be true. Both statements have to be true. So and, what we're looking at is really a section of line contained by 2 points. And is everything in the middle. And's included. Well, if we look at the graph, it's going in opposite directions. So most likely we're looking at an or statement. Most all and inequality statements are going to have 2 definite endpoints. It's going to be everything in the middle. So we look at this first part of the statement here. Well, we're saying that it's everything less than or equal to -3. So x is less than or equal to -3. Or we could write it the other way and say -3 is greater than or equal to x. Okay, well that gets rid of C. Now for the other side, we're saying x is greater than or equal to 2. Well, that leaves us with what? D. Because it might be tricky to say E, but this is actually telling us that x is smaller. Any questions on this here? All right. Let's look at the next one here. 2, which of the following is a possible value for B if 4B minus 6 is equal to 14? Well, one method we could do is actually plug the values in. Because we could start off with 0 and see what the absolute value of 4 times 0 minus 6 is. Well, 4 times 0 is 0. 0 minus 6 is, well, I wrote 0 again. Would be -6, and the absolute value of -6 is 6. Well, that's not 14. Very slowing on slides. Okay, then I could go with -1, 1, 2, -2, and try those to see if they work. Another way we can do this is actually getting this thing equal to 0 by subtracting 14 from both sides. So we can say that the absolute value of 4b minus 6 minus 14 is equal to 0. Okay? You might be wondering why that's helpful. And the reason that's helpful is we can actually grab the graphing calculator. Because if I get it equal to 0, we can actually graph it. So I can hit y equals. Now the main question that y'all might have is absolute values, because we don't see a key that has absolute values. Well, under math, if we hit math, well, I don't see anything there. And go over to numbers, ABS. Does not stand for automatic braking system. Okay, that's fine. It's absolute value. So we can actually graph an absolute value function. So we had 4x minus 6. And if we cursor outside those absolute values, we could say minus 14. And hit graph. And well, where it's 0 is where it crosses the x-axis. So any spot it crosses the x-axis would be a value for it. That would make it be 0. Well, we have 2. One's at -2 and one is at 6. Second graph. So one's at 5 and one's at -2. So -2 and 5 both work for this here. Now, did it give us both of those points? Well, no, it only gave us one of them. So the correct answer here is -2. So a lot of these here, even if it's an inequality, we could actually get it set equal to 0, get one side be 0, and find it from there. Any other questions on this here? Well, let's look at the last one. A certain lizard species can only survive in a temperature that falls in the range of 77 degrees to 95 degrees. Given that Celsius is equal to 5/9 times Fahrenheit minus 32, where C represents the temperature in degrees Celsius and F represents the temperature in degrees Fahrenheit, what is the corresponding range in degrees Celsius at which the lizard species can survive? Well, do any of these ranges have the same minimum or maximum value? The same top or bottom? No. I'm going to just take 95 and say 5/9 of 95 minus 32. Well, we can plug that into the calculator. Or if we did this by hand, it'd be 5/9 times 63, which works out to be 25. Well, 25 does show up twice. It shows up once in D and once in C. But we know 25 is at the low end or the high end? 35, thank you. That makes more sense. I knew it ended in a 5, I just couldn't remember the first number. Because this is actually 7, yep. So 35, yes. That makes more sense. So, well, we actually also do have 35 showing up twice as well. But we came from what? The max. So that means it has to be D, because D is telling us 35 is the max. E is telling us 45 is the maximum temperature. Now we could have done the same thing with 77 and actually gotten our 25. So it would have given us the low end, which would have also signified that one out. Questions on this here? All right. Learning targets, solving inequalities involving variables, using number lines to visualize the graph, and simplifying absolute value equations. Apparently I'm deciding to write. I'm putting all these up here because I feel like this here is rehashing something y'all done before. Most inequalities, because if we look at it, the first one is less than. We have greater than, less than or equal to, greater than or equal to, or equal to. Y'all have used these before because we've done them in Algebra 2, Algebra 1, 8, 7, 6th grade math. You've done inequalities many, many, many times up till now. Yes. Dealing with the, I think it's on the next slide, the alligator, yes, because that was the analogy that's been used time and time again, and it always opens to the bigger number. Well, now, absolute value, this is where a lot of people have trouble with inequalities and absolute values. Because the absolute value is the distance from 0, regardless if it is positive or negative. It's just the distance from 0. How far are we away from 0? So the number inside the absolute value could be positive or negative. And one of the biggest things with absolute values, B, value B, here with these inequalities, we're dealing with and or statements. We're always going to have two. Now, the main way I've kind of remembered it, or as I've seen the best way to deal with this, here we're saying the absolute value is great or than, great or than, and I know that's not how you spell greater, but great or. Because if the absolute value is great or than a number, we're dealing with an or statement. If it is less than, we actually have an and statement. With absolute values, we have less than or great or than. And this can sometimes be helpful because here great or, we're looking at something that's going to have 2 points, and it's going to be facing in opposite directions. For and, we're going to have 2 endpoints, and it's going to be everything in the middle. And especially if we're looking at graphing, that helps us, because any that's less than and not between the two doesn't work. If it's great or, then we have something that looks like this here. Those answers don't work. And we'll look more into that here in a little bit. Well, why don't we just go through these here, because this is included in your note sheets, and probably y'all have already blown through it if you've looked at it already. Because we have 3 and 2. What would we have? Greater, less than, greater than or equal to, less than or equal to. Oh, going the wrong way. Greater than. 70 plus 9 and 80 minus 2. Because 70 plus 9 would be 79. It would be greater than, because we would have 79 and 78. So it would be greater. 2,237 and 2,732. Less than. 3 times 5 minus 7 and 2 times 6 divided by 3. It would be greater. Because on the left-hand side, 3 times 5 minus 7. So according to order of operations, we do what first? Multiplication. So the 3 times 5, which would be 15, and 15 minus 7 is 8. 2 times 3 divided by 6. What do we do first? Because again, please, or the order of operations is parentheses, exponents, multiplication and division left to right as they occur. So 2 times 6 is 12, and 12 divided by 3 is 4. Yeah, with our addition, subtraction, multiplication, division is always those together left to right as they occur. Here we have 2 to the third and 4 plus 2 squared. Well, 2 to the third is 2 squared is, so 4 plus 4 is, so they would be equal x plus 1 and x plus 2. Be less than, because x for a variable in any expression is always going to be the same. Any variables that are the same will have the exact same value. So for this here, I'm going to erase all the ink. So let's say x is 2. Well, we would have 2 plus 1, comparing it with 2 plus 1 is 2 plus 2 is. Well, any value of x I plug in, we would still get the same comparison, because if I'm adding 1 to it and the other 2, well, the one with 2 should be bigger. All positive integers in 1. All positive even integers. What is the smallest positive even integer? 2. Well, since that's the smallest one, it's always going to be greater than 1. What's the smallest positive prime number? Okay, so prime number is a number that has factors of only 1 in itself. It's not 1, it's 2. Because 1 is positive, but again, the definition of prime numbers is it has factors of only 1 in itself. Well, 1's only factors is it doesn't have another number with it. We don't define it as prime. The other issue comes into prime factorization. Prime factorization is the products of, say, so 4, all the numbers that multiply together to give us 4, all the prime numbers. So we can say 2 times 2, yes? And if we included 1 as prime, we can say this here, yes? Can I actually write 1 enough times? No, because I keep adding multiples of 1. It really just screws everything up. So kind of those two reasons, they've excluded 1 as a prime number. 1 was prime, but I think it's somewhere in the 1800s, they actually removed it as a prime number. So it's been a while. Five twelfths and 1/3. Five twelfths. There's several ways we can go at this, especially with ordering fractions. If it's hard to tell, turn them all into decimals. Let's grab the calculator, see what 5/12 is as a decimal. See what 1/3 is as a decimal and compare those. Because 1/3 is 0.3 repeated. 5/12 be 2. No, it's not 2 because it would need to be bigger because 5 goes into, or 12 goes into 50. Yeah, 416. So we can see that the 0.4 is bigger than the 0.3, so that would be the bigger fraction. So turning fractions into decimals especially, I think we've gone over ordering greater, less than, turn them all into decimals. It's easier to work with. And last but not least, the number of boys in the class compared to the number of girls. There are definitely more girls in the classroom than there are boys. We got what, 3, 6, 9, 10, 11, 12. 4, even if I include myself, that's still 5. It is definitely less than. Now, I threw that all up at once. But the point that this here is trying to make is that the way that we solve inequalities is not any different than what we do for equations. How we can solve an inequality in an equation are the exact same. So what we would do first is our distributive property to go from here to here. We would subtract 5 and divide by 3, and we get to our answer. Same thing is true with inequalities. We're doing the exact same thing. Now, again, the one we started out in the example problem, well, we had absolute values and inequalities, yes? Well, I got it equal to 0, so we could take and I could subtract 22 from both sides. 2 times 3x plus 5 minus 22 is less than 0. And this seems kind of a funky way to do it, but it's just getting it to 0. So any value of x for this here, we want it to be what? Less than 0. I want it to have a value that makes y less than 0, yes? I'll come over here. Clear that out. Say 2 parentheses 3x, I think is plus 5 and minus 5. I've already lost it. It is plus 5 minus 22. On that. Plus 5 minus 22. And I can graph it. Now, it's not going to graph it like an inequality, but we know whatever the value of x is, needs us to give us a value of y that is less than 0. Well, second table, so I'm looking for where all the y values are less than 0. Well, the first number where it's actually 0 is at 2. And I want all the y values that are less than 0, so we're looking at where x is less than 0. So it tells me, well, for this here, x would equal 2 if we solved it, but for the inequality, x is going to be less than 2. It kind of gives us an idea of what to look for, or what we're looking at. Questions on this here? Now, the only real big hiccup, if you can call it that, with multiplication and division, or with inequalities, is that if we multiply or divide by a negative, we've got to flip the sign. Multiplication and division of a negative really changes the sign. Otherwise, there's no real difference between them. There's no real difference between these two here, especially when solving. Because whenever we divide both sides by a negative, we've got to flip the inequality sign. We've got to change the inequality sign from positive to negative or negative to positive. Because whatever values we plug in for x is going to change. Because if we said x is 1, well, 1 times negative 5 is still negative 5, yes? It's not really changing the overall value. Actually, I just remembered the example I wanted. I want this here. I'd set it up exactly like the other problem. Now, say I plug negative 2 in here. Negative 5 times negative 2 is what? Positive 10. Yes, a negative times a negative does give us a positive. If I look at the other side, negative 25 times negative 2 is negative. Oh, wait a minute. This number went from negative to positive. This number went from positive to... So they ended up both switching sides, yes, on the x-axis. If we looked at the number scale, negative 5 is now on the positive side. Positive 25 is now on the negative. Well, if they're switching, this sign has to switch also. That's kind of why we have to flip it with when we add or multiply or divide by a negative. That sign has to switch accordingly. That's really what we have going on here. To be able to see that. Well, I could have subtracted 25 and graphed the thing. Negative 5x minus 25. Equals negative 5x minus 25 graph. Go to, where did I mess up? I know where I messed up. But I didn't fully clear that out. So we said this here, yes? Well, again, we want it to be greater than. Well, where's the first number that is greater than at? Right there, or second table. So we need x to be greater than 0, where the first place it's greater than 0 is at. And all the y values that are greater than negative 5 is our negative 5 going up that way. So it actually works out to be our x is less than negative 5, because it's all the values of x that are less than negative 5 that make it true. Questions on this here? The graphing calculator does make these a little bit easier, yes. It doesn't help us understand the actual principles or properties that are going on with all these here, but it does get us to the answer a lot faster. Now we'll stop there and we'll pick this through the day.